Hey geometry students, welcome to our next video lesson in Unit 7. We are learning about right triangles in this unit. We've learned about doing Pythagorean theorem with right triangles. We've learned about special right triangles. Now we're going to look at a really cool use, which is trig. Trig comes up with right triangles specifically. And we're going to learn about trig, or the full word is trigonometry, which is a little bit of a mouthful. You'll also see these new vocab words come up: the sine, the cosine, and the tangent. We do have shorthand for them. SIN for sine, COS for cosine, and TAN for tangent. A lot of people accidentally say like sin, cos, and tan, but it's supposed to be sine, cosine, and tangent. So we'll look at these vocab words in the video, but just a preview, these are some words that you're going to see. So we're going to kind of see why we use trig. Like, where does it come up? So we've previously seen finding missing sides of triangles in the context of 45-45-90s and 30-60-90s, right? These are some shortcuts where if you only have one side, you can find both of the other sides, whereas previously in Pythagorean theorem, we needed 2 out of 3. So go ahead and pause the video and use the one side length clue to find your other 2 missing sides using our patterns from the last couple of weeks. Okay, so there are your 2 sides. Remember 45-45-90s, legs are equal. The hypotenuse is the leg times a square root of 2. And then for our 30-60-90s, you have your hypotenuse, which is twice as long as the shorter leg. This is called the shorter leg. Sometimes you might call it the base, but remember we've seen that sometimes they might be turned a different direction, where this isn't necessarily looking like the base it's sitting upon. And then your longer leg, or what you might call the height in this diagram, you multiply the shorter leg by root 3. And these are really useful because we don't necessarily need 2 sides out of 3 to get the third, right? Pythagorean theorem, you need 2 to find the missing. This is kind of a nice shortcut. But what you'll see is for something like this, our rules only apply for those specific angle measures. So a 37-degree angle, I don't have tools to help me find my missing sides. So what we're going to look at today is a tool that helps you find missing side lanes with just an angle as well as a side. So we're going to kind of be moving in this direction. So here's where we're going to introduce the new vocab word: sine, cosine, and tangent. And all these 3 things they're basically taking a right triangle and you are doing a ratio of 2 sides. Right, we've done ratios before. If you think about examples, like if I've got marbles, here are some marbles here. If I want the ratio of red to blue, right, I can write that in 2 different ways. I can write that as 3 to 2, or I can write it as a 3 over a 2. And we're going to be mainly thinking in the context of the fraction idea, right? So a ratio is just a comparison, thinking back to where we've seen it before. If I'm focusing for all these, it says to focus on angle A. So the reason why we want to focus on angle A is because we're going to be looking at it from A's perspective. And we're going to label the sides. I'm going to label this one as my hypotenuse. From A, this one's across from it. I'm going to call this one the opposite side. And then the last one, this one is called your adjacent. I'll write them all out fully because it's next to angle A. So you have the hypotenuse, which remember that's always across from the right angle. The opposite is across. And then adjacent is the side that is next to angle A, not being the hypotenuse, right? That one's kind of its own thing. So using A's perspective, sine, cosine, and tangent, all they are is just fancy notation for telling you a certain ratio. So the sine is always the opposite over the hypotenuse. And if you had actual side lengths, you would put how long the opposite side BC is over how long the hypotenuse is. Cosine is your adjacent side over your hypotenuse. And the last one, tangent, is your opposite side over your adjacent. And there's no special you know, it's just basically sine, cosine, and tangent were created because mathematicians found the ratios of these sides pretty frequently, so they wanted to have a way to talk about them rather than always saying find the adjacent side and put it over the hypotenuse, right? They wanted to have a shorthand for how to talk about that. And so what we'll see in a moment is we'll see actual side lengths example. Some students have found that an acronym that helps them remember this is SO, CA, TOA. And it tells you sine is opposite over hypotenuse, right? Cosine is adjacent over hypotenuse, kind of going like that. And tangent is going to be opposite over adjacent. It goes in order, right? You can think about it like that. Some students also prefer to think about it a little bit more visually, and they'll write it like this. However you prefer is fine. But remember, all these it's just directions for finding a ratio of two sides. We're just comparing two side lengths. And so let's look at what this actually looks like, right? It's a little hard to see what it looks like without thinking about it. So I'm going to write my acronym. So, CA, TOA. I'm going to do it like this to remember which one's on top and bottom. So notice I've got A, so it's from the perspective of angle A. So I'm first going to go ahead and label, okay, this one is opposite of A, it's across. 5 is my hypotenuse because it's across from the right angle. And 4 is my adjacent. It's next to angle A, but it's not the hypotenuse. So remember, sine is opposite side over hypotenuse. We're just comparing two side lengths. In this case, I actually have side lengths, which is lovely. I've got a 3 over a 5. So the sine of angle A is just saying, tell me what the opposite side is over the hypotenuse. So it's just giving us directions. Cosine, adjacent, 4 over hypotenuse, 5. And then tangent, I gotta do opposite over adjacent. Opposite is 3, adjacent is 4. So these are just comparing sides. We're just finding ratios of sides of right triangles specifically. And then if I look at number 2, this one is looking at the same triangle, notice, except for I've got a new perspective. Right, I'm doing the perspective of angle B. So that means that what side is your opposite and adjacent, they're going to change. Notice, in this case, from perspective. My hypotenuse stays the same, but my adjacent and my opposite are kind of flip-flopping. So go ahead and pause the video and find the sine, the cosine, and the tangent based on angle B's perspective. Okay, double check your ratios and take a look at that. Notice they're going to be different from before, right, because we're on a different perspective. Okay, and then one final problem that we'll look at. This final problem is really similar, except for we first need to figure out what side AB is, right? We don't know what that side is. I'm going to call that X for now. And what we're going to do is we're going to be using the Pythagorean, I'm going to write it all out, theorem. So you can really nicely see that what we started our chapter with, we're going to continue using. So remember, smaller side squared plus other smaller side squared added together is equal to the hypotenuse squared. Remember, hypotenuse is across from your right angle. I'm going to square those. Okay, doing my solving, getting x squared by itself. X squared is equal to 64. Now that means if we think about it, x could either be 8 or negative 8, but negative 8 wouldn't really make sense, right? A negative times a negative is a positive. But for length of a side, only positive 8 would really make sense in this context. So now that I've figured out what my missing side is, I'm going to label that as 8. And now from here, you guys are going to do it with the perspective of C, right? So make sure, go ahead and label which side is opposite, adjacent, hypotenuse, and go ahead and practice finding those 3 ratios and unpause when you're ready to check. Okay, double check your answers. Notice I've got my mnemonic device at the top to help. So that's it for the first notes video. Feel free to move on to notes video 2, where we're going to look at how to use this to help us find a missing side. That's going to kind of go back to our question on the front page of how could we find some missing sides here. If you would like to stick around, I've got a mixed and an honors level problem. This is going to be similar to what you'll see in the homework. So feel free to stick around if you want to try out the honors level problem with me. Otherwise, you're good to go into video 2, finding sides with trig. So if you're sticking around with me, this mixed problem is kind of interesting. They're telling us the sine of angle A is a certain ratio and the cosine of A is what we're looking for. The tricky thing is I don't have a visual. So anytime I don't have a visual, I'm going to draw a triangle. And that's why this one's more of a mixed level problem. It's a bit trickier. So I'm going to make a right triangle. I'm going to call this angle A, maybe BC, let's say. I'm going to get my angle, and from the perspective of angle A, this side is going to be opposite. This is going to be hypotenuse, and this is going to be adjacent. Remember, adjacent is kind of whatever is left over after you do opposite and hypotenuse. And they've told me that sine, right, so sine is opposite over hypotenuse. That's equal to 3 over 5. So opposite side is going to be a 3, and then hypotenuse is going to be a 5. And I need the cosine, right? Cosine of angle A. That's going to be SOCA adjacent over hypotenuse. I sometimes just have to say it out loud or draw it, the mnemonic device for myself. But I don't know the adjacent side. So what we're going to have to do to figure this one out is we're going to do Pythagorean theorem to figure out adjacent. So we'll do 3 squared plus x squared is equal to 5 squared. 9 plus x squared equals 25. If I move the 9 to the other side, subtracting 9 on both sides, I'll get 16, which means x has to be 4. Negative 4 would also square to be 16, but we want a positive for a side length. So my cosine is going to be adjacent 4 over hypotenuse of 5. So this one is a lot harder just because you have to do the process of drawing the triangle, figuring out a missing side, and then being able to do your ratio. Now we're going to think about the same problem. So we've already got the background, but we want to figure out something further. The perimeter of ABC is 60, and we want to find the length of the hypotenuse of the triangle. And what's tricky about this one is the fact that our triangle that we're looking at, we know that the ratios of the sides give us the 3, 4, and 5, right? But here's the interesting thing. I'm going to put the 3, the 4, and the 5. Just because I know that sine of angle A, right here, is equal to 3 over 5, doesn't mean the sides have to be 3 over 5, right? If I did the ratio and I had like 6 over 10, right, if the side lengths were 6 and 10, that would simplify to 3 over 5. So think about it as we can scale these up or down by the same amount. So to do that, I'm going to call this 4 times something, 3 times something, and 5 times something. And this is really coming from the idea of scaling it up or down, right? It's simplifying to 3 over 5, but it might not start as 3 over 5. So if I add these all up, right, assuming there's some multiplier, I don't know what it is, the total is supposed to be 60. With that in mind, I've got 9 x's, 10, 11, 12. X's is equal to 60. If I divide by 12, it's telling me my multiplier is going to be a 5. So let's double check what that would look like. Here's angle A. If I do that, it's going to be 4 times 5 is 20, right? 3 times 5 this side is going to be 15. 5 times 5 this side is going to be 25. Oops, sorry about that, a little messy. There we go. Some tech troubles. So notice if you do sine, right, opposite over hypotenuse, that would be 15 over 25. Notice they're both divisible by 5, so it does simplify to 3 over 5. So these can apply to scaled up or down versions of the triangle. So you have to be careful with problems like this. It might not necessarily be that those are the actual side lengths. And they want us to find the hypotenuse of the triangle. It's super tricky, right? We want to be careful to find the answer. So the hypotenuse of the triangle, right, we want to make sure you read the directions, is 25 units. We don't know what the actual amount is. It could be inches, centimeters. Perfect. You guys are all done. Thanks for sticking around to watch the honors problem with me. and work through it. Go ahead to video 2 where we'll look at how to use trig to find some missing side lanes. See you guys then.